Welcome, good people. This is section 2-5 transformations, and this is going to be the first day that we're going to be spending on it. So we're going to start off with a function, and that's the y equals x squared function. Here it is, it's plotted. And you notice on the notes there's a big table, and the text has on the first line it has x squared plus a number. It's x squared plus 3. And so actually, if you were to graph that, the difference between this g of x and f of x is the plus 3. So you can see here, this is what's making the difference. If there's no value of d, then the two functions are the same. But if you add 3 to it, then all the points get moved up 3. You can see the y values go from 0 up to 3, from 1 up to 4. The y values add 3. The x values stay the same. We call this a vertical shift. Actually, the book calls it something different, but I'm going to simplify the language, and I think we're going to be able to use language that is just as powerful and describes all situations, except it's going to be simplified. So if you look at the back of the book, sometimes the answers might not perfectly line up, with the vocabulary, but I think it's going to be a lot simpler for us. So check this out. In line 1, what you can write is g of x is, when they give you x squared plus 3, you can say the d value is 3. And that's because we're just going to call the location in the function right here d. The parent function is x squared. It's basically an x squared function that has a vertical shift of a positive 3 units. So is it vertical or horizontal? Well, you can see it's been shifted up vertically, and then we call that a shift, and it's up 3. How many units? By how far? It's by positive 3 units. All right, so check out line 2. You can see that it's not plus 3 anymore, it's minus 1. And you can guess that if we slide this down, it's going to be minus 1. All the y values are subtracted by 1. The x values stay the same. X is still 0, 0, but you go from 0 down to 1. You go from 1 down to 0. It's what we call a vertical shift of negative 1 units. That's because the d value, there should be a negative 1 right here. Okay, so here's line 3 on the table. You can see that it's basically going to be, the parent function is still something squared, so we can still call this the parent function. However, the number is in a different spot. It's x minus 4 units. So if we slide this a value up to 4 units, we can see that the whole parabola has just been shifted to the right 4 units. The y values are still the same. It's still 0 and 0, 1 and 1. However, you take these x values and add 4 to it. So we can say that this is, the a value is 4, and the parent function is x squared. It's a horizontal shift, positive 4 units. Now this might, I'm going to put a little star here, an asterisk, because you can say that this might be a bit the opposite of what you might expect. The formula down below defines a to be positive when x minus a, because x is minus. This subtraction here reflects the fact that when you move this parabola 4 units to the right, it's positive. We can call this positive 4 units here. This plus 4 corresponds to this plus 4 because this is subtraction. Check out the next line. If you wanted to do plus 1, then the a value would have to be negative 1. When it's x plus 1 inside the parentheses, when it's x plus 1 being squared, the a value is negative 1. And you can see it's a horizontal shift, negative 1 units. I try to avoid right and left language because I think it's a bit easier to always say horizontal shift of negative 1 units. A different place for the number, let's say it's being multiplied out front. Oh, and wait a minute, we need a different parent function. I think this has to be x cubed. The parent function here is going to be x cubed. By the way, you can see a list of parent functions that commonly come up on the notes. There's just various options. This is the cube function. And so what happens when we take this c value and make it 2? All of a sudden, the y values have been doubled. This one stays the same. 0 times 2 is still 0, but 1 doubled. 1 times 2 is now 2. And so we can say that this is the c value is 2. This is, and the parent function is x cubed. This is a vertical dilation by factor of 2. So dilation can be like stretches or shrinks. The book doesn't use the word dilation, but a dilation is a category that includes both stretches and shrinks. And we're just going to say it's a dilation by factor of 2 because it's been stretched. All the y values have been doubled. It's been stretched up twice. Now, what happens if we make that a fraction out in front? If we make that a fraction, then you see the y values get cut in half. The c value is 1/2. The parent function is x cubed, and it's a vertical dilation by factor of 1/2. You can see here 0 times 1/2 is still 0. 1 times 1/2 is 0.5. Okay, so we have the absolute value of x over b. Now, if we let b be the number that x is being divided by, then we can see that we need a value of b of 2. It might seem as though it's being flattened, but actually it's being stretched twice as far. You can focus on these 2 points right here. You can see how when b is just equal to 1, they're on top of each other, but then this other point gets stretched to the right. So actually, we're getting stretched horizontally. The b value is 2 because we're defining b as what x is being divided by. And so therefore, it's a horizontal dilation by factor of 2. It's being stretched horizontally twice. And this might be opposite of what you expect. You see a fraction here, you might think it's a shrink, but actually, since b is going to be divided by 2, we can see that the x values get doubled. The y values stay the same, it's 1 and 1, but the x values are doubled from 1 to 2. So what does this look like when it's 2x? Well, technically, 2x is the same thing as being divided by 1/2. We have to take the reciprocal here, and the reciprocal of 2 is 1/2. So now, it might look like a vertical stretch, but really, if you're adjusting the b value, then it's a horizontal dilation by factor of 1/2. That might be opposite of what you expect when you look at the equation. You might expect this to be a horizontal dilation by factor of 2, but in fact, it's the reciprocal of what you might think. You can see it here. The point goes from, the x value goes from 1 to 0.5. Okay, here's line 9. You can see from the equation, it's pretty complex. There's 3 different numbers all working at the same time in the same equation. However, it's basically just a square root function. So I can see that it's a square root function. Let me type in square root of x. And a square root function that's been modified and transformed 3 different ways. You can see that there's an a value of positive 2, like this. There's a c value of positive 3, like this. And there's a d value of 1 here. This a value is a horizontal shift plus 2 units, a vertical dilation by factor of 3, you see how it got stretched, and a vertical shift of plus 1 unit. So the real question comes up, if you don't have a calculator, how are you supposed to do these transformations? Well, the basic strategy is going to be to individually, point by point, transform them. And so first let's transform the 0, 0. It starts here, but then it gets horizontally shifted 2 units. Then it gets, so you can see you have to add 2 to the x value, go from 0 to 2, 0. Then vertically dilated by factor of 3, you can see this point doesn't move anywhere, the other one does, but 0, the y value 0 times 3 is still 0. So dilations, when you have a 0, this still stays anchored to the x-axis in this case. And then you have to do a vertical shift of 1 unit. You can see how it goes up 1 plus 1. So starting at 0, 0, you horizontally shift, then vertically dilate, then vertically shift. And it goes in, the order really depends on PEMDAS. So you can see you do what's inside the parentheses first, and then you do multiplication, and then you do addition. And it goes in A, B, C, D order here. But that's why I named them A, B, C, D. Do the A value first, and then the B value if there is one, and then the C, and then the D. Okay. So let's do the same thing again for this point here, 3, 4. How do we, if we don't have a calculator, or we don't have Desmos at our side, then how do we plot that point? How do we know how it gets transformed? So we start with the parent function, point 1, 1, and then we have to go A, B, C, D order. That's PEMDAS order. So first, horizontally shifted plus 2 units, like this. You can see how it goes from 1, 1 to 3, 1. Then vertically dilate it by a factor of 3, so the y value is 1, and then the new y value is going to be 3. And then vertically shift it up 1 unit. So the y value is 3, you're going to add 1 to get 4. All right. By the way, did you know that Phoenix is the capital of Arizona? Yes, that's quite the audio check, isn't it? Phoenix is the capital of Arizona. So, that's the video. I'd like you to begin assignment 2E1. And what that means is just copy the problem list and begin the first problem. I can't wait to see what you come up with. I'll see you in class. Take care.